Okay, so this is just a really brief overview of how to name hydrocarbons. First of all, you need to have carbon and you need to have hydrogen. Otherwise, it's not a hydrocarbon. So if you have oxygen or something in there also, this doesn't apply. So the first thing you need to remember is that carbon has 4 valence electrons, which means carbon can form 4 bonds, and it has to. So that's 4 lines. Each of these lines represents a bond, and you should hopefully remember that. So at the end of each of these lines is the valence electron, and the line that connects them means the bond. So notice how this carbon in the center has 1, 2, 3, 4 lines coming out, which means 1, 2, 3, 4 bonds. So 4 bonds. Hydrogen has 1 valence electron, so it can only have 1 bond, which makes sense. So here's this hydrogen. Now I notice that this line isn't going directly to the H, but it is bonded, okay? So nothing else can come off of here because that would mean there would be more bonds to hydrogen, and that's not possible. So this is our first structure. We make sure that these things are both accurate, and if they are, then we can go ahead with naming. We're going to need reference table P and table Q. These are both found on reference table page 7 of the chemistry reference tables. So the first thing you need to do is ensure that we are a hydrocarbon, which we are. If you had oxygen or nitrogen or something else, you'd have to look on table R, which is on the next page, but we don't, so we're good here. So the first thing you do is you count up your number of carbons. I have 1 carbon. On table P, 1 carbon means the prefix meth. Okay? The next thing we do is we need to figure out the kind of bonds. So the bonds here are all single bonds, 1 line between the carbon and the hydrogen. And since they are all single bonds, you look at table Q, and the picture in table Q that has all single bond is called an alkane. So alkanes have all single bonds, like this one does here. So an alkane has the suffix or the ending ane. So this is called methane. Okay? So you break this apart. This is the number of carbons. You break this apart. This is the types of bonds. Okay, so let's check the next one. So the first thing we need to do is make sure carbon has 4 bonds. So this first carbon has 1, 2, 3, 4. That's good. This middle one has 1, 2, 3, 4. That's good. This last one has 1, 2, 3, 4. That's good. Hydrogen only has 1 line coming off of each, so that's good. So it is a hydrocarbon, nothing else. Then let's figure out the number of carbons. 1, 2, 3. So looking on table P, 3 carbons is the prefix prop. Then the next thing I need to do is figure out the number of bonds. Now look, everything is just 1 line in between. So that means this is an alkane again. So if you are an alkane, the suffix is ane. This structure is called propanes. Prop meaning 3, ane meaning all single bonds. Okay, so there's going to be a couple questions like that on your quiz. Please make sure you use tables P and Q. Now, this structure looks a little different because you notice, hopefully, first thing you notice is this. That is called a double bond. So remember, carbon always has to form 4 bonds, and it still does. 1, 2, 3, 4. It's still 4 bonds, but it's not to 4 different items. It's just 4 different bonds to 3 different items. And so notice this carbon, 1, 2, 3, 4 bonds. So everybody is still satisfied. Carbon has 4 bonds, hydrogen has 1. But this is a double bond, which means the suffix or the ending is not going to be ane, it's going to be ene. On table Q, alkenes are substances, hydrocarbons, that have a double bond. It could have more than 1, but all it needs is 1 to make it an alkene. Now let's figure out what that prefix is. 1, 2, 3, 4, 5, 6 carbons. If you look on table P, 6 carbons is hex, hexene. Now, the last thing you have to do is because The double bond is a unique structure. We need to tell the location of the double bond. If you feel good with hexene, this next part is kind of like a detail that's not super important, but I still want to tell you anyways. So we number the carbons left to right. 1, 2, 3, 4, 5, 6. You always want the double bond or unique structure to be coming after the smallest number possible. So if you look here, the double bond comes after the second carbon. So we call it 2-hexene. But don't forget, carbons and hydrogens and these molecules can rotate in space. So just in case, let's number it from right to left. 1, 2, 3, 4, 5, 6. So if we number it this way, the double bond comes after the fourth carbon. So which is the correct name? The one with the lower number. So these numbers are not what we use. We want to number them with the smallest numbering section possible. Like I said, if that's confusing, this numbering part, that is not as important to me as figuring out hexene, okay? The last kind of hydrocarbon is called an alkyne. Notice a triple bond here. That's 3 bonds between those carbons. Carbon always has 4 total, 1, 2, 3, 4, 1, 2, 3, 4. But instead of having 4 different items, they're only bonded to 2 different items. So if this is an alkyne, the suffix is -ine. You don't need to memorize this. It's on table Q. Then we need to figure out the prefix. How many carbons? 1, 2, 3, 4. And I'll number them. 1, 2, 3, 4. 1, 2, 3, 4. Only one of those numbering schemes is correct. But before we get into the number, let's figure out the name. 1, 2, 3, 4 means butane. Finally, if you read it left to right, the triple bond comes after the 2. If you read it right to left, oh look, it's also after the 2. So because it's in the middle, it doesn't really matter. Both ways, it is 2 location butane. So the 2 tells you the location of the unique structure, but tells you how many carbons, ine tells you the types of bond. Okay? So I hope that helps. Take care.